Hello, world. Happy to have you all back here at the Global AI Community on virtual tour. With me as co-host is also Eve. Hi, Eve. Welcome back.
Hi, thank you a lot. It's
Hope you
awesome
had
to be
some
back.
rest.
Yes.
So, for our next speaker, we have Mikaeri. Mikaeri is a Microsoft MVP. She's mostly working, of course, with artificial intelligence and machine learning already since 2017. She was the first woman in Brazil nominated in that category, so congratulations on that. She's also received the title of Google Developer Expert in Machine Learning and is a community manager for communities like WoMakers Code Developers Brazil and supporter of AI Brazil and NerdZao. So, welcome, Mikaeri. How are you doing?
Hi, I'm fine. How are you?
We are good. Thank you very much. We're very glad to have you on board for the next session. But before we kick off, we'd like to ask where you're located and in what time zone you are at the moment.
Yeah, I'm from Brazil, and here it's 6 p.m.
Okay. For us, like for me, it's now 11 p.m., so there's quite some time difference.
A little bit late, I think.
Yeah, exactly. All right.
Yeah,
Mikairi, you're going to talk about how to start a career in data science. Quite interesting. A
yeah.
lot of people want to change the or make a career move. So the platform is yours. Go ahead.
Hi,
Hi,
everyone.
everyone.
It's a pleasure to be here. Thanks for your time and everyone who's watching. My main objective here is give some tips and help who wants to enter in the data science market or just know more about this area which is growing so fast. I'll give some tips and I would really appreciate if they help someone. Well, let's go to the presentation. So my name is Mikaeri Ohana. I'm 22 and I'm from Brazil, actually in a city called Jundiaí from the state of São Paulo. I'm currently working as a data scientist at CNT, helping companies grow with data. I was awarded as Microsoft Most Valuable Professional in AI category and Google Developer Expert in Machine Learning category due to my contributions to the community. And this is something that I'm really proud of and makes me want to continue in this journey of sharing knowledge. Also, I'm a tech and career speaker who likes to talk about machine learning, data science, communities, women in tech and career, such as the importance of soft skills and technology, for example. Well, this is an overview about me and what I have been doing for the community and in my life in general. Well, let's go straight to the content. The amount of data we produce is increasing year by year. Along with this fact, there is the discovery that this data can bring immense value to the business and that it can influence important decisions in the most diverse sectors, giving rise to the statement of data is the new oil, as we can see in this chart, with the comparison between the years 2010 and 2015, 25. That is very important to see this growth that we can see that's so important and emphasize the importance of data nowadays in your lives, in your career, and in our daily routine. The amount of data that we produce is really large. These are some of the factors that make the data science career among us the most sought after by several companies, as it's possible to see its growth through this chart below with data acquired by LinkedIn. So I will present an overview of this career, address some of the main points in this area for those interested in reinventing themselves as a data scientist, and tips and suggestions from someone who has been through a lot of what's here, made mistakes, learned, and wants to help make this journey as pleasant as possible for people interested in coming aboard this ship. If you didn't get it, ship has a relation to Titanic, competition, Kaggle, and I think that you will understand the pun later. But yeah, how did I get started in the area, in the data science area, data science career. So nowadays I work as a data scientist for a project of international company in the brewing industry. I started my career in data science, working on site in this history from 8 a.m. and 5 p.m. in early 2019. The interesting part of all this is that before 2019 even began, I had already started along this path and I was head over heels in love with it. It all started in June 2018 at an event from Microsoft called Xamarin Summit. That was a really good event. The company I worked for at the time was a sponsor of the event and held some slots for the employees to be panelists. I have always been involved with community since college. I gave lectures, I published articles, answered questions in forums, and contributed in any way I could. The company asked me to take one of these slots in light of communication skills and the fact that I had already created some mobile apps using the technology that I was covered during the event. I have already created some mobile apps using Xamarin, and this was really great for me to. It was easier for me to explain some content because I had already some experience with the subject. I accepted the invitation without hesitation, since it was the first time I would be panelist for a company I admired dearly, and it was such a big event. I still remember the way I felt that day. It was incredible, seriously. And the time had come for me to choose the theme and prepare the content. At that moment, I was a C# developer, advancing my career path to a senior. I hadn't been involved with the mobile world for a few months, and I was no longer aware of the latest news from technologies and different frameworks. What could I bring to the table that would be different and at the same time would add something for the audience that was about to watch me? So I was wondering what I could bring, how could I be important for the crowd that will assist me, that will see me presenting something. What kind of stuff could I bring? So, and then after a lot of research, I got to know the subject of chatbots and natural language processing, speech to text and text to speech. And was thinking like, is that topic interesting? Let me check. Yeah, it is. Let me know if natural language processing is something that people want to learn. Yeah, people want to learn that. Is this topic already present in the grid? Not yet. So, oh, Eureka, we have a topic. So I finally found what I needed to talk about, and this made me very happy. And here you can see the page of the website. How was the website at the time that I was going to present, my name and the topic that I was going to talk in a few minutes. And then I started to structure my lecture. I found a tutorial on the internet about cognitive APIs. I started calling them within the application I have developed, and the chatbot was taking form. I developed a chatbot for Rochelle's Beauty Salon, Chris' mother from the show Everybody Hates Chris. And as it was the same time as the World Cup, Neymar, who is a Brazilian soccer player, was talking to her looking for a hair loss treatment. Hair loss is like, I made a joke because Neymar is a soccer player that used to fall down during the gameplays. So I wanted to make some fun with the crowd, and they all laughed in the day. It was really nice moment. And on the day of the event, everything went well. I lectured on the subject, and many people talked about it after and liked it a lot. During the event, I met many people that I admired that had the title of MVPs. It stands for Microsoft Most Valuable Professional. little did I know I would share their title 1 year later. And this is something that makes me very, very proud of. Something very interesting. Well, I went home extremely happy and willing to continue studying the area. Which year day that went by, I became even more interested in understanding what was behind those APIs and what I had called in that day. What was those APIs? What is these APIs? What's behind it? What is this black box? So I wanted to know what's the accuracy. I know that I retrieved this to the application, but how is it done? How about the calculus behind that information? And I wanted to know how they return that information for me as a client, the application that consumes this data. So I started to study mathematics, statistics, machine learning modules, and everything related to data science, creating my own APIs and therefore understanding what was behind the black box. In September 2018, I talked to the CEO of the company I was working with at the time about the desire to create an artificial intelligence area on site. I showed him how applications could bring valuable insights to the business and everything I had studied so far. I continue as a professional developer, but every day when I got home, I was immersed in another science. I wanted to focus on that. Because I was so determined to do it. So I went to work on it all day, not just when I come home and I have a little time to study. I went to do it for my career and I was decided to do it. So this new area was created after I was able to prove the value it had and make myself available to train employees to work on projects that involved data. I created a study plan, carefully selected the content that they should learn to get their hands dirty. I started several tips of preventing them from going through the many difficulties that self-education had put me through, and that I value. I really think that the self-education is very, very impressive and very valuable for everyone. But they make the path for me needlessly tortuous. It was kind of hard when you don't have the structure of your knowledge, of your learning path. So I try to bring that stuff to the people that I was going to teach, and this helped them a lot. They learned it so faster than I learned at the time that I was learning data science for the first time. And so the area that I had dreamed of was established. Our first project arrived, and along with 4 other people, I was responsible for its success. I found myself happy and fulfilled as I acted as a leader of the company's first data science area, and I managed to put it into practice all the knowledge that so much time studying had given me, as well as training people with the little experience I had. I had other experiences with data science. I began working on new challenges, and today I continue looking to impact business and people by making data speak. Did I started with the math? No, I started by the end. I had a goal and I started unraveling it. Sorry for the mistake in pronunciation. I started by APIs, and then little by little, I understood what was behind them. In my view, that made things easier. Once my training was mainly in software engineering and not in mathematics and statistics. So start by the end helped me with know my objective, and it's easier when you know where do you want to go. It makes the journey so you have more pleasure during your journey of learning. It's very, very impressive thing that I want to share as an advice for everyone who is trying to learn something and have some difficulties. difficulties in some topics, as I had in mathematics and statistics when I started learning data science. Well, but what is data science? Actually, let's go through the topic, understanding its concept, and going through to the list that I'm going to talk today about some advice that I'm going to give to you. So before we start to listen the interesting reasons why to enter the area of data science, it's important to define what this area is. So data science in general is the area that studies the data and takes relevant information from it. It's through data science that hypotheses are tested and validated. When we have a specific problem to be solved using data, or that the exploratory analysis takes place when you have a large amount of data or dispersed data actually, and we will draw conclusions and correlations from them. So we have a lot of data, we cannot organize it properly, so we go through the exploratory analysis to see what we can catch from this data so dispersed. And the main target of this area is to extract such data, interpret it, and present it effectively to the end user, leveling the language according to the audience with which it communicates. So knowing how to present it to technical people and people who have no knowledge of the subject. This is so important. We need to level it. We need to talk at the same way that people has the knowledge. We need to know how to communicate. This is one of the points that I will go through. And data science has kind of an umbrella, like we have some roles that I will talk mainly about 5 of them, but if you make some search, you'll see that we have a lot of different roles, and each one has its specialization. So with the growth of this area, some aspects of the data science pipeline took on large proportions and needed specific professionals to take care of their correct progress. Those professionals understand the pipeline as a whole with a generalist review, but they also see each of these areas according to their preference with a more expert eye. So, well, let's start from the top. We have the data analyst. Data analysts are the specialists in reports and visualizations. They are professionals who assist in decision-making from the information they generate and communicate. They analyze information obtained from the process and make connections between them, translating them for daily usage. There is a greater focus on answering questions and generating your answers quickly and accurately. The second one is the data engineer. The data engineer is the professional focused on data extraction and treatment of data. They specialize in the process of obtaining data from the most diverse sources, and are able to treat them in order to ensure that the machine learning models receive the necessary inputs to make the correct predictions. They are responsible for data modeling, mining, and parallelism, often using ETL tools like extract, transform, and load for this process. The third is the machine learning engineer. The machine learning engineer is responsible for improving the capacity and performance of the predictive models created, and are responsible for ensuring that these models will perform well when in a production environment. They have a great knowledge of machine learning algorithms and architecture, from modeling to monitoring, ensuring that the scalability and a consistent continuous integration and continuous delivery pipeline will happen. The fourth is the data scientist. The data scientist is responsible from the beginning of the problem conception process, assisting the business area in its decisions and the path that must be followed with autonomy and creativity until the solution is delivered. Employs machine learning methods for preparing predictive models, exploring opportunities and trends. This is a person who from all areas has the greatest understanding of the end-to-end process. Being able to build predictive models and present them to the business area in an understandable way without losing their scientific base. It has great mathematical and statistical basis. So it's one of the professionals that has the most structured mathematical context. It's very well. He knows very well these topics. He or she. Well, the last one is a statistician. It works mainly with the data scientists using the statistical knowledge they have for creating and managing predictive models. Well, they have the ability to use theories, probability, and mathematics to transform everyday problems and find their solutions. This is the professional who has the least amount of contact with software engineering and the most contact with statistics and linear algebra. So we have here different kind of professionals. We can see that some of them are most focused on software engineering, and in other hand, we have other ones that are focused on calculus, on linear algebra, trying to improve our precision mechanism of your models, and we have others that are totally focused on the entire pipeline and guarantee that this will work in any environment that we want. But before we start, I want to align some expectations. I know that everyone here wants to see the list, the famous list of how to get started in data science area, but this is an image that I like so much because the most common mistake for someone entering data science is to believe that they will only create machine learning models, but this is a lie, like this image shows. What do you mean clean all this data? This was sold to me as the second job of the 21st century. So the creation of machine learning models happens indeed, depending mainly on the subcategory you choose to dive into. However, even if you choose an area that mostly creates models, you will not do this 100% of the time, because this is an area that companies are still trying to grasp how to implement. So you probably do a lot of things outside of your role, and this is okay. You need to accustom with this situation, because companies are still understanding how to implement data science to get this kind of professional into their board. So sometimes you need to do something that is not in your role requirements, but this is something important for you to do, because we understand that the market it's kind of new. If you see, the growth is new, and we need to understand it and help companies to achieve this objective. You may come across data that's totally disorganized, and this is the second point, because I think that the image is true. Or you may not have enough data. You need to treat them, clean them, make them uniform. If you don't have a good database to work with, and you don't have a good notion of feature engineering, that is the process of turning raw data into valuable data that best represents the problem for predictive models, you won't have a model that works properly and can become frustrated. Well, this is the two main points that I think that's very important to know before you start learning data science. You not do this machine learning. You will need to to focus mainly on data. That is the most important thing in every single data science pipeline. If you don't have the correct data, you cannot guarantee that your machine learning model will work properly. So it's very important to pay attention in the beginning of the process if you have everything under control, or you need to make some like I said, feature engineering stuff to get things to work. I said my idea that data science is about a pipeline as whole, not just algorithms or machine learning models. Well, the list that I have done has quite a lot of information, so quite a lot indeed. Don't try to take in everything at once. I'm also improving myself in each of these points, and I do not consider myself fluent in all of them, especially because our area is the one that constantly is changing the most, and we find new points to study every single day. So make the learning process a pleasurable experience. And this is my main advice here before we start. And let's go to the list, shall we? So business analysis and understanding. First of all, it's always important to remember that technology is a means, not an end. At the end of the day, what will really add value to will be the results generated from the implementations we make, whether they involve tool X, UI, or Z. Working with a business, it so happens that there is often a problem to solve that seems like a shift, and a better understanding is needed. Sometimes there are no problems at all. Important skills are critical thinking, problem solving, and a sense of urgency. How do you achieve this when you want to get into the area but you don't work with it nor or any project related with it? The Kaggle website has a series of projects that you can use as a starting point to exercise your ability to organize your thoughts and draw a line of reasoning that makes it possible to solve the problem. In addition, there are several competitions on the website which allows you to actually simulate a scenario where you need to have a quick thinking. Another tip is to use notebooks like Jupyter Notebook or Google Colab to document your line of reasoning and simulate how you would present the information you collected, from its starting point to its conclusions. This can be useful later on when creating your portfolio that we'll talk a bit in the future of the presentation. The next one is languages and programming. Yeah, you will need to program. In all sub-areas, programming is important. The only difference is the language that one employs more than the other. Knowledge of programming languages like Python and R is important. You don't need to be an expert on both. I suggest you to choose one of them and specialize in and know its limits and differences when compared to one another. I, for example, chose to specialize in Python, and it has served me well in all aspects until this day, for having support both for building algorithms and for exposing its APIs on the web, because it has Flask and Django frameworks that helps us a lot. There are other languages such as Java and C that are used instead of Python R in a few projects. I argue that once you know programming, what differs most between one language and another is the syntax and the way of implementation, but the logic to solve the problem is still the key. Databases will also be used a lot. Relational and non-relational DBs can come on your way. That's why it's important to have knowledge of SQL like Microsoft SQL Server, NoSQL like MongoDB, or Cosmos DB helps us a lot too, Spark and Scala, and move on to Hadoop, Hive, Kafka, and MapReduce to cover big data solutions and be able to participate in discussions about this type of subject. Still on programming, not forgetting points like scalability, tests, clean code, code versioning, and good development practices are crucial. This kind of concern was part of my years as a web developer, and they are still present even as a data scientist. That's nice to focus on. The second slide is about machine learning. So there are many machine learning models, several already pre-trained with different data, which are ready to be used. It's important to understand here what these models are for and the types they fit into. For example, we have the supervised, that is the training data is in the algorithm training data set, and sorry, let's go to the beginning. The training data set in supervised models has the categories called labels of the modeling output. Basically, we show where we want to go. For example, we have a line that shows as the output needs to be a dog, another dog, another cat. So we know where we are going. And this is called supervised models. And examples of that are k-nearest neighbors, linear and logistic regression, support vector machines, decision trees and random forests, and neural networks. The next one, the unsupervised, the training data is not in the training data set, and the system will try to reach the output through similar properties between each piece of data without guidance or assistance. So we don't have the dog and the cat at the final of the line. So we need to see its properties and see what they have in common. Examples of these algorithms are k-means, hierarchical cluster analysis, principal component analysis, and so on. Semi-supervised, the training data that's in the algorithm training data set partially has a category. So sometimes we have cats and dogs, sometimes we don't. So that's why it's called semi-supervised. We cannot guarantee that all the lines has its labels. And for reinforcement, in this type of learning, the model is called an agent, and it carries our actions in search of rewards, always aiming to increase this number. It's like training your dog and giving him a cookie whenever he lies down, for example. Well, I have added a list below that you can see in the screen with examples of the many existing models, each being used for a specific approach. Understanding regression, of course, you don't need to remember all of them. This is something that you need to see when you're going to start a project, and you see all the models that you can use, and you can choose one of them to study and to start. You don't, please don't start learning all of them. You will go crazy. Understanding regression, classification, clustering models is very interesting and will make you stand out when looking for an opportunity in the job market. Datasets. Datasets are used for training and testing our models. It's common for them to be in .csv format, separated mainly by commas, but if your problem is with image classification or segmented analysis, the format will be kind of different. An important point here, do not think that the dataset will arrive perfect for you to use. What I mean is that the data can come with several anomalies from the source. They may have one type of separator in one part of the document and a different type in another. They may have missing fields that are crucial to the module, or you may need to obtain other data from those received as an important variable. In the last case, feature engineering, which I mentioned was at the beginning of this presentation, comes into action. Let me see. Okay. Some of the points of datasets that needs to be paid attention to are insufficient amount of data. Pattern recognition in images, for instance, requires millions of examples. So take care of your inputs. You need to put the correct amount of data to guarantee that your algorithm will work properly. So data is the main thing of each data science pipeline. Balanced number of observed cases. Imagine that you have a system that will distinguish positive and negative feelings. If you have 9 lines of the dataset with examples of positive feelings and only 1 line with a negative feeling, you are biasing your model to have a positive output. Due to the great number of positive examples that has trained it to respond the way. So keep your data, your training data balanced with the same amount of labels, of the same amount of data for each label that you are going to use in your project. This is very important, and it will help you to achieve the correct output at the final of the pipe. And metadata quality, in this case, examples are data full of insignificant characters, various blanks, and other types of noise that interfere with the pattern recognition of the model. So the model will start to be crazy because we start to go crazy. I don't know what pattern should use. What has this blank in the middle of the phrase? So we need to take care with the inputs that we are going to put in your models. This is something very, very important. Statistics and probability. Well, predictive models use mathematics and statistics in their construction. And I discovered that after studying them and understanding in depth how they work, to say that it will not be necessary to understand statistics and mathematics is a lie, because to deliver value to the customer and ensure that everything works properly, it's important to know how things work behind the scenes and the calculation made behind the outcome of the inferences. Here are some of the important topics in statistics and mathematics applying to data science that you will encounter on your journey. So we have calculus, linear algebra, calculation of probabilities, graph theory, distributions, mean, median, and mode, Bayesian inference, and hypothesis tests. Now let's take a break. What if you told me that you didn't know this whole bunch of things? It's okay if you don't know, really. It can seem super difficult at first. Have in mind that primary education reinforcing your brain from early age that people who are good in math are brilliant, and therefore creates a difficulty about the topic in your heads. I suggest that you look at the problem first, then look at the algorithm, understand the theory, and then go to the practical math of it. Trying to understand all the concepts at once can stress you out a little, and it's quite a lot, and you don't need to everything on a first project. So the important thing here is to know how to make exploratory analysis to find correlations, understanding what your present is and what your future will be through data from the past, what the numbers are showing. So keep this in mind. Don't try to understand all the things at first moment. Well, tests within the data science field are very different from tests performed on software engineering projects. They are really different. That's because we are working with a lot of math and data, which are not like the methods of software applications. There are several metrics here. The metrics of the module, ensuring the success of predictions are correct in calculations. The business problems that we are working on, and engineering, which guarantee the functioning and the performance. Some examples of the metrics that are from the several ones that exist are accuracy, precision, recall, F1 score, log loss and binary cross entropy, and area under the ROC curve. And get familiar with this, that is the confusion matrix. It makes the results available in a matrix and divides them into true positives, false negatives, and true negatives and false positives. So it's very important. It helps us a lot to understand the output of our models and what do we need to correct to make it work properly. We are almost finishing, guys. We have, I think that we have 11 or 12 items. Pipeline. Data science is a very robust pipeline. It goes from the conception of the problem to the presentation of the results and the following up and monitoring of the model in production. That is why it's very important to have a generalist thought of how the whole process will take place. Even if you choose to focus on any of the sub-areas presented, I think that is really relevant that you know at what point you are contributing in the chain and how to discuss ways to improve the process as a whole. So it's important for you to participate in this kind of discussions. Some questions you should ask yourself in this step are, how do I version the data that was all that added to my data set? How do I implement CI/CD? How can I monitor my model and if, after implementation, the results are being presented as expected? How to deliver results without prejudice or bias? Try to answer these questions and you'll see if you are paying attention in the pipeline step of data science. Portfolio, to conquer your first position in this area that is constantly growing, my tip is to have your projects added to GitHub, very well documented and explained, assuming you are explaining to a layman. And if you have the opportunity, make a website. A good project to begin is the Titanic project available on Kaggle. Very interesting overview of it you can see on this simoidal.ai website that helps to understand each part of the project and how you can put your efforts where to put your efforts in the project of the Titanic. That's very good to beginners. Well, data visualization and data storytelling. You have done the exploratory analysis, drafted some proofs of concept, got your hands dirty to clean up the data and leave it in the standard form to be used in the chosen model. Done the test and take the metrics online and offline. It's enough story to tell, and in your mind everything is very clear and we know where we stand. Now, how to tell the story to stakeholders and people impacted by the results obtained? It's extremely important to study data storytelling, which is the art of storytelling through data, and data visualization related to how we represent data clearly in a self-explanatory way for the public. In order to achieve your goal in showing the impact of certain decisions and make the results and the results of our hypothesis raised, we need to work through many variables. Choosing the information to be represented, choosing the best charts to represent the information, and the last one, choosing the order to represent the information until the result is achieved. Because a presentation that does not have a clear line of reasoning for representing the data is a lost presentation. So that's the three main points that is important for you while you're presenting some data science pipeline to the business or to the technical tech people that is working with you. So yeah. Methodologies. A methodology is a strategy used to guide processes and activities within a given domain. Examples of agile software methodologies are Scrum, Kanban, and XP. Data science has also made its contributions to project management methodologies, and not so many people are aware of this information. Some of them are ChrisDN, SIMA, and KDD that you can search later and see where to use one or another. It's very important because they can help you to structure your first data science project. Communication, soft skills are extremely important in any area and tend to be even more so in technology. Being a software developer who communicates and knows how to exemplify your ideas in a simple and objective way, engaging with the person you speak can also help you to achieve success above the rest. Because of that, it's a paramount to focus on how you express your ideas, to know how to have a dialogue and reinforce your points of view, and to translate that whole technical context that you and I know that can be quite complex for lay people who are often more interested in knowing whether or not you got there than in the process itself. Network and personal branding. In this step, I want to reinforce how you can present yourselves to other people. I have a live chat that can help you understand that better. If you search on YouTube, you will make your code Mikaeri, and it will appear myself explaining Portuguese how to work with your personal branding as a developer. And it's important that you, the developer, are able to show what you have done and how to sell yourself with confidence and self-love. Know how to sell your ideas, projects, everything you have achieved so far, and to demonstrate that you are prepared for the challenges that are yet to come. Networking goes hand in hand with personal branding. Having a network of contacts can help you achieve fantastic opportunities and help you start in the field of data science, like you have dreamed of with just one click, adding the right person. A clear example of this: imagine that you are on LinkedIn and I add a person who works for the company I always wanted to be part of. That person can like a post I made about data science, and someone from the person's network can see that this person liked my post and notes that my engagement is very great and with the subject. So and so on until the opportunity arrives. So we just need we have I heard sometime that we each just just six people separate we from any person on earth, and I truly believe this. So going to the communities, we are almost finishing. Technology communities are great for any looking to get started in any area. They are a source of networking and can provide you with free content and people willing to help you without asking for anything in return. I strongly recommend that you join one of them and introduce yourself, showing how much you want to learn and contribute. Here are some examples of them. So I would really appreciate if you take a look on each of them, see how can you contribute, and how they can help in your career. That's very, very interesting, and I truly recommend you to do it. The last one, English. Last but not the least, the English. I'm from Brazil, so English is not my main language, but I'm not native English speaker, and I wouldn't say English is necessary, but it's a big extra in most job vacancies. If you're not comfortable with your level of English so far, I find it super advantageous that you look into improving it by taking courses with private teachers or using apps just as Duolingo. In addition to helping with vacancies, it will also help you after joining the company. Most of the content I access about data science is in English. That includes articles, courses, datasets, work tools, forums, etc. You can only gain by improving your language skills. You can talk with suppliers in an easier way and more confident way. So resume your expectations. Take it easy again. It's an area that never stops and will never stop. If you are standing still, there is something wrong. But enjoy the learning journey. Do not be discouraged and disencouraged. It's not easy, but will be worth it. Start your engines and let's go learn with me. So that's it. It was a pleasure to be here again. Thanks for everything, and sorry for any mistake that I made during the presentation. We are we are all learning, and I include myself in that point too.
Thank you very much, Mikaeri. We were very glad to have you. It was a very interesting talk. We do have some questions, so we still have some time for some questions. We have one person who's asking, what programming language for machine learning would you recommend to start with?
Oh, nice. Well, my personal opinion would be to start with Python. Python is a great programming language for machine learning, and it's very easy for people who who don't program or don't have experience with programming. So I truly recommend Python, and the community of Python language is very helpful. So you can ask and solve your doubts in a lot of forums, and people will try to help you. I can guarantee.
All right. Some people also asked if you are willing to share your slides.
Yes, I can.
Yeah. All right. They will make sure that gets to them.
Yes. So what were your biggest challenges when you started on the field of data science?
Oh yeah. The biggest challenge I think it was I didn't have a person to help me like a mentor, and like I did with the people from the area that I said in the beginning of the presentation that I helped to create with. So this was the hardest part. Know what to learn and where to search it. It was the hardest part of the learning path that I took, but I think that it helped me in some way with more. Uh, I grew in a faster way because of that, because I have created another skill that is know what to search, structure what I need to do in every situation of my life. So that was the hardest part, but the most the one that I'm most grateful for.
Okay. Thank you very much. Are there any online courses that you would recommend to people? Like this is really a good one that you should follow if you want to start a career in AI or data science.
Okay, I know that Microsoft has a lot of online courses that can help you to know more about the end-to-end pipeline and so on. So you can have an idea of the whole process. It helps you a lot. We have also the Coursera has a lot of great courses that goes in depth of the mathematical context and statistical context too. So you can start by learning the pipeline with the Microsoft courses and go through the Coursera, Udacity courses that can help you too in solving your doubts. And going through your learning path, you have some specific doubts, and for that, I recommend you to search this topic specific because you can learn and like remove it from your doubts. So you have the generic idea, and since you already know each part of this path, you can advance in your path. But when you have specific doubts, don't make a big course for that. Search the specific doubt, and since you cleared it, you can advance and go to other courses that will cover more of your learning path.
Okay. Well, we just got in another question. I think this was going to be the last one also. Do you know of any free data science projects available online that are fully completed end to end so people can just look into it and learn out of it?
Yeah, you can see on Kaggle, we have, in Kaggle is a online platform that has a lot of projects, so you can see what people developed and their documentation. So it's very nice to understand how to implement and what to document when you are going to do your first project of machine learning. So I would really recommend Kaggle for that.
Thank you.
Thank you a lot.
Mikaeri, thank you very much for your insights on this topic. We appreciated your time and the effort you put in this session. Well, for now, for all who's watching, we're having a short break, and after this, we will have Seth Juarez with the next talk. So see you in a bit.
Bye.
Hey, my name's Akanksha Malik and I'm from Melbourne.
Exit Sami with Val here.
Hi, I'm Alan Smith.
Hi, I'm Amy.
I'm Prasant from California.
大家好，我是卢建辉。Nederland.
I'm Ralph Cassie from Australia.
Hi, I'm Jennifer Marsman from the United States.
Hi, I'm Arpita Gupta from India.
Hi, I'm Matthew Renton from the USA.
I'm Joe Spizak from California.
Hi, Medin Eddie Daoud, Greece, Ghana.
Hi, I'm Ana Famana.
Merhaba, ben Türkiye'den Daron Yönden.
Hi there.
Hi.
Hi.